Hi everyone, today we're going to be looking at solving equations but from word problems. You've already practiced solving when you've been given the equation or a model, and now we're going to be looking at word problems where they don't directly give you the equation. I'm going to start by reading this first problem. We're going to do two examples. Brody rode his bicycle on 2 different days. The first day he rode 7 miles per hour and started 1 mile per hour from his house. The second day he started from his house and rode 10 miles per hour. What is X, the number of hours that Brody would have to ride his bicycle to travel the same distance on both days? So I'm going to start in the question by what it's asking. It's asking what is X. So we're going to go ahead and define the variable. What do you think X represents? Right after X, it says the number of hours. So X is representing the number of hours. Number of hours. And it's referring to Brody riding his bicycle. Now, it says how many hours that Brody would have to ride his bicycle to travel the same distance on both days. The keyword same is telling us that we're going to have an equation here. Each side is going to represent each day. Now, we're going to go ahead and start from the beginning again because it tells us the first day and the second day. So we can go ahead and label one side will be day 1 and one side will be day 2. It really doesn't matter which side each of them go on, but I'm going to go in the order of the problem. So let's go ahead and start with the first day. The first day he rode 7 miles per hour. How do you think we'll write that on the left side of this equation? We know we're going to write 7, and we have this keyword here, per. Per is a very common word that we're going to be seeing in a lot of these problems. Per means we're going to multiply per hour, and X represents our number of hours. So it's going to be 7 times X, which is 7X. Now, this is not the only part for the first day. It says 7 miles per hour and started 1 mile from his house. How do you think we're going to represent him starting 1 mile from his house? Since we're starting away from the house, we've already gained this mile, so we're going to have it as a +1. Now to look at the second day. The second day, he started from his house and rode 10 miles per hour. He rode 10 miles per hour. How do you think we're going to write that on the right side of the equation? It's just like the 7 miles per hour, but instead of 7, it's 10. So he's riding a little bit faster at that rate. Now, we said for the first day that he started 1 mile from his house and we had a +1. For the second day, it says we started from his house. So how do you think we're going to represent that in the right side of the equation? Since we're starting at his house, that means we're starting with 0 miles. Now, this is not necessary to write in your equation, but I wanted to show you what that represents in the equation. So this is one way to write it. Once you have it written like this, you're going to solve it like you normally do, using the steps that you've used before. Now, this is not the only way that we could write this equation. We could also write 1 plus 7x equals 10x. Or you could have it reversed. You could have 10x. You could have 10x equals 7x plus 1. Either way, you get the same solution for x at the end. How about you go ahead and solve this equation and write in what you get for your solution? Okay, let's go ahead and move on to our next example. Okay, our next example. Sierra has a bucket that originally contained 340 fluid ounces of water and is being filled at a rate of 5 fluid ounces per minute. Brian has a bucket that originally contained 650 fluid ounces of water and is being drained at a rate of 8 fluid ounces per minute. What is X, the number of minutes that need to pass in order for the 2 buckets to contain the same amount of water? Now, we're going to go ahead and start out our problem the same way we did the first one. What do I want you to do first in this problem? We're going to do the same first step that we did in the first problem, which is define our variable, and our variable is x in this problem. equals. What does x represent in this problem? In this problem, the x represents the number of minutes. Number of minutes. That need to pass in order for the two buckets, so we're looking at two buckets, to contain the same amount of water. Now, we said before, same is telling us they're going to be equal. Actually, I'm going to move that up just a little bit. Equal. Okay, now for this one, we could say bucket 1 and bucket 2, but it's specific here, okay? Because Sierra has a bucket and Brian has a bucket. So we're going to go ahead and label them by their names here. Okay, let's go ahead and start with Sierra because she comes first. Sierra has a bucket that originally contained 340 fluid ounces of water. That's how much water was in the bucket to begin with. So we're going to go ahead and write 340 for Sierra. And it's being filled at a rate of 5. It's being filled at a rate of 5 fluid ounces per minute. How do you think we're going to write the rest of Sierra's side of the equation? Now I see this word per again means the same thing. Now, because we are filling up the bucket, we are filling it up, it's going to be a positive 5x. 5 fluid ounces per minute. And we're filling up the bucket. We're putting more water in it. Okay, now let's go ahead and look at Brian in our second bucket. Brian has a bucket that originally contained 650 fluid ounces of water. So we're going to write this the same way we did with Sierra. Instead of 340, Brian starts out with 650 fluid ounces of water and is being drained at a rate of 8 fluid ounces per minute. How would you write the rest of Brian's side of the equation? Now we have a different word here. Instead of filling, we have the word drained. Drained is whenever you let all the water out. You can think of a bathtub or a sink. You're letting all the water out. And it's 8 fluid ounces per minute, so we have 8 times x. Now, you can solve the equation just how it is right here, but you can also solve it if it's written another way. So we could have it reversed where we have the 650 minus 8x on this side, and we have 340 plus 5x on this side. You would get the same solution if you did it that way. Also, I want you to see what's another way we could write it besides that way. The other way you may write this, and this may feel more comfortable to you, is 5x plus 340 equals negative 8x plus 650. Now, do y'all remember what form this is called? This is called slope-intercept form. This is the way that you write your equations in y equals mx plus b. And this especially makes sense here because we have a rate of 5 fluid ounces per minute being filled up, and then we also have a draining rate of 8 fluid ounces per minute. And also we have the word originally. This is our original amount. This would represent our y-intercept. It's the original amount that we have. Either way, no matter how you write it, where it's on either side or the terms are flipped, you still will get the same solution. Go ahead and solve this problem to see the solution that you get.